All right, so there's this problem on that we were discussing today in class where you have an object on a ramp and you're trying to find the acceleration of the block and the time it took to get to the bottom. Looks like it went 20 meters. So let's see, start it out. All right, so I'll make this block here my system. Okay, a dotted line around it. There's my system, and my force diagram will be weight, and then normal will be up at an angle. Okay, and that's it. So I got two forces acting, normal due to the surface, and the weight of the object, which I'm going to call mg. Okay. And then if I draw a reference line for my surface would be in this direction. Okay. And I'll draw a horizontal reference line. And I'll draw a vertical reference line. Okay. And it looks like my 40-degree angle is pretty clear. It's going to be here, but it's also going to be right there. And if I draw a reference line that is the tail of that vector, you'll see also that every other angle is my 40-degree angle. Okay, that's quite a common situation. And then if I redraw my vectors head to tail, I can do this in any order. I got normal up, I got weight down, and if I scale my vectors to their correct length, there will be a missing vector that is the sum of these vectors, and the sum of these vectors is going to go from the tail of the first vector to the head of the last vector by rules of vector addition. And there it is right there. I drew it in red. That's going to be my net force. In other words, my vector that is normal plus weight, and it's going to have a magnitude of ma. Now, you can see from my reference angles that my 40-degree angle is right there, right? So this is the easy way of solving the problem, okay? Sine 40 degrees is going to equal ma over mg. So the acceleration is going to be g sine 40 degrees, right? And if I wanted to find normal force, I could do it. I would just have to use cosine, right? So I could also figure out things by using cosine 40 degrees is going to be equal to normal over mg. So in other words, normal is going to equal mg cosine 40 degrees. Okay? So that's how I'd solve this problem just naturally using a non-traditional type method. I drew a force diagram. I drew some reference lines. I made sure I was careful about figuring out my angles correctly. And then I drew my vector sum diagram to find out the length and direction of my net force vector. And I also made sure I realized that my acceleration had to be down the ramp for the block. So I made sure my ma vector was in the same direction as my acceleration. Okay, and I found the magnitude of my acceleration right there. I also found the magnitude of my normal force. Okay, so I made this. This screencast was a non-traditional method. Now the next one will probably be a little bit longer, and I'll do the same problem, but with more of a traditional type method that's a little bit more confusing, but it works just as well. All right, see you later.